Hello, hi, namaste. This is Surabhi, your master teacher of chemistry at Vedantu. Welcome to Sprint Alchemy. This is our 11th session, so where we will be solving some important questions of the following topics: vital force theory, classification of organic compounds, nomenclature, isomerism. And this is the entire schedule of Sprint Alchemy. We are already here. Thank you so much for being with us from past 2 weeks and watching all the videos of Sprint Alchemy. If you have not watched it yet, go back and watch it because those questions which we have discussed are super important. And if you are here for the first time, if this is your first video, or if you have not subscribed to the channel yet, make sure to subscribe to the channel, hit the like button, share this video with your friends, and click on the bell icon so that you will be notified whenever we are live or premiering the videos. Thank you so much. Don't count the days, make the days count. So this world is a scary place, and we have these expectations that we have to reach, but I want you to realize or understand that life is not only about achieving things or being a successful human being. No, it's more than that, because we have given this limited amount of time on this beautiful place. So how are you spending each moment? It counts, right? So I don't want you to, yes, learning is a beautiful thing. Every day I want you to learn something, but not for the sake of marks, or not for the sake of some the expectations that has been set by the people around us. No, do it for yourself. Do what you like, because at the end of the day, it's you who will sit back and think, so what did I do? Was my life worth it? Am I happy? Was I happy? So please try to be happy. I know there will be difficult days, but make sure that you still have that beautiful smile on your face at the end of the day. Okay, here is the first question. What has happened to our structure? Oh ho. Write the IUPAC name of the following. So don't worry, I know it. So it is CH2, CH3, CH3, CH2, CH2. Yeah. So 1, 2, 3, 4, 3. So this has to be 3, right? Yeah. So this is the structure, I believe. But why are there CH2 groups? No, this is the right structure. So what is the IUPAC name of the following? See, IUPAC, it's not neopentane. If you write neopentane, you won't get marks. Okay, so write the IUPAC name of the following structure. So this is the structure, I believe, because how can there be CH2 groups, right? The valency won't be satisfied. Don't you think so? No? Yeah. So 1, 2, 3. I'm taking this as the carbon chain, the main chain. So the root word will be pro, and I do not see any multiple bonds, so I'll write propane. So here to the second carbon, 2 methyl groups have been attached. So 2, 2 dimethyl. I should have written it somewhere else. Just give me a minute. So 2, 2 dimethyl propane. This will be the structure. CH3, CH2OH and CH3O, CH3R. What kind of isomers? Position isomers, chain isomers, homologs, functional group isomer. No, they have two different functional groups. So it's not about position or chain, because they both are straight chain and homologous series. They do not have same functional group. The right answer will be D, functional group isomers, because here you can see alcohol functional group, but here this is an ether functional group. There are two different functional groups, but the molecular formula of the two compounds are same, so they are functional group isomers. Question number 3. Which part of an organic compound determines physical properties and which part of an organic compound determines chemical properties. So physical property is all about the alkyl groups. Remember what happens in the homologous series, the characteristics of homologous series, you remember that point? So there will be gradual change in the physical properties. Why? Because the molecular mass is increasing, and that molecular mass is because of the alkyl groups, right? So the two homologs, the consecutive homolog, it differ by a CH2 unit, and the molecular mass is 14 unit. That is the difference. So the physical properties, maybe you can find the difference. That is because of the change in their molecular mass. That is because of the groups. है ना? Chemical properties is solely dependent on the presence of functional group. What kind of functional group is present in the given compound? So physical properties, the alkyl group determines the physical properties, whereas the chemical properties is dependent on the functional group, because that is how we define a functional group, है ना? Which just infers or which gives a certain set of properties to a compound. So that is what a functional group does, है ना? Okay, so this was a very easy question, right? No? Question number 4, we have 2 sub questions, so 2 marks के लिए. Name a few sources of organic compounds. We can name a lot of them. Give the various applications of organic chemistry. So first is name the few sources of organic compounds, the petroleum products and plants, animals, right? So we do get wood, we get the organic compounds, they can be extracted from these sources. Give the various applications of organic chemistry. See, in the synthesis of most of the compounds we use organic compounds, right? Maybe the fiber which we use in our clothes, or the medicines, or in the manufacturing of the to extract the petroleum products, you have those organic compounds. Name anything, shampoos or the perfumes or the medicines, we use organic compounds there. So you don't have to write the same ones, but make sure that they are actually related to organic chemistry, okay? So give the various applications of organic chemistry. So it is used in the production of soaps, shampoos, saponification, perfume, esters. So various fuels like natural gas, petroleum, they are also organic compounds. Imagine our life without them. The fabrics that we use to make various dresses, they are also made from the organic compounds. Question number 5. Explain the following. Tetravalency catenation. So what is tetravalency? कार्बन का वैलेंसी है 4, है ना? Because what is the electronic configuration? 2 4. So it has 4 electrons in its valence shell. But the problem is, we already know how to determine the valency of the elements, right? It depends on the number of valence electrons. Here, carbon can neither lose nor gain 4 electrons, neither lose 4 electrons nor gain 4 electrons in order to attain that octet electronic configuration. So the only option left is it has to share all the 4 electrons with other carbon atoms or other atoms like hydrogen, heteroatoms, in order to get that stability by having 8 electrons in its valence shell. That is the reason its valency is 4. That is what is the meaning of tetravalency. And catenation, it is a self-linking of carbon atoms to form straight chain compounds or the branch chain or the cyclic compounds, right? So this is a special property exhibited by very few elements, and one of them is our carbon, and the bonds formed by the carbon atoms, the covalent bonds, are very strong and stable, so that allows the carbon to form long chains of compounds. So this property is known as catenation. So tetravalency, carbon can neither lose nor gain electrons to attain octet. Thus it shares 4 electrons with other atoms. So this characteristics of carbon by virtue of which it forms covalent bonds is called tetravalency of carbon. Next is catenation. I have already told you, but let me just read it again. The property of self-linking of atoms of an element through covalent bonds in order to form straight chains, branch chain and cyclic chain of different sizes is what is known as catenation. And carbon-carbon bond is strong. So they might ask you why carbon-carbon bonds are strong, why it exhibits catenation to that larger extent. That is because of the smaller atomic size. You should know the reason as well. Okay? Want to join us, gain 100% knowledge and score 100% marks? Yes, here we are teaching everything. We have different kinds of series like thoughts, assertion, reasoning, case-based study, sawal aapka, jawab hamara, everything. But still, we are not 100% efficient. I agree. How? Because I'm the only one here. When I'm taking the live session, I might miss few of your doubts. Right? So even though we will have doubt session and everything, so I can't say we are 100% efficient. But there is a platform where all of your doubts will be solved instantly. You don't have to wait for another session after a week after the completion of the chapter, because getting your doubts resolved is super important for your conceptual clarity. What if I say there is in-class doubt solving with class teachers and a master teacher who make sure that all of your doubts are being solved then and there. You can attend such amazing classes every single day, any number of sessions. Yes, unlimited live classes with fun and high-level quizzes. Compete with the students throughout the world. We are not talking about state or India, throughout the world. And if you couldn't watch the session, manlo, then also you can go back and watch the replay, still play the quiz and be on the leaderboard. So the handwritten notes can be downloaded, which is super useful. And there are different kinds of courses like micro courses, crash courses, absolutely free for you. Less is more. How? Only here. More number of classes, lesser the price you need to pay. And we have this amazing offer going on, but it is a limited period offer. So you can get 50% off up to 1,500 rupees. The link is in the description and in the pinned comment. But make sure to use the coupon code SURPRO. Surpro it is. Okay, let's get back to our organic chemistry now. 2 marks ka question hai. Let's see. Write any 4 properties of organic compounds that distinguish them from inorganic compounds. That's nice. So first is solubility. Organic compounds, they dissolve in the organic solvents, like dissolves like, and they, the reaction also. So organic compounds generally, the reactions won't be spontaneous. Okay, so even though if we talk about alkenes, alkynes also, so they are kind of more reactive than the alkanes, right? But still, if we have to talk about the reactions, so they are not very reactive. Like, if you have to compare with the inorganic compounds, so obviously organic compound will contain carbon. That is the main substituent, main composition, like the composition of organic compounds, all of them has to contain carbon, right? And formation of covalent bonds. In inorganic compounds, most of them. So if we talk about, for example, inorganic compounds, I say NaCl, NaOH, most of them, majority of them will have ionic bonds, having low melting and boiling point. So this is the common property of all the covalent compounds, right? Okay. Question number 7. What is an alkyl group? Give the name of any 3 alkyl radicals. How are they formed? So an alkyl group is formed when you remove a hydrogen atom from an alkane. You agree with me? Yes? Chalo, let's try. I have CH4. Minus 1 hydrogen atom. I'll end up getting CH3. So this is what is an alkyl group. So the group formed, or substituent formed when a hydrogen atom is removed from an alkane molecule is what can be called as an alkyl group. So an alkyl group is obtained by removing one atom of hydrogen from an alkane molecule. So alkyl group is named by replacing the suffix. So we have methane. So this is the alkane from which I can obtain this alkyl group. So what will I name it? So I'll remove ane, I'll add the suffix yl, methyl. Okay, so this is how the alkyl groups are formed. So next question is, give the name of any three alkyl radicals. How are they formed? Methyl, ethyl, propyl, butyl. So how are they formed? Just remove one hydrogen from the respective alkane groups. So CH4, CH3 plus H plus. CH3 are ethane. So you will get CH3, CH2 plus H plus. We are removing hydrogen atom, but it is not taking any electrons with it. Okay, so it will come out as a proton, H plus. No electrons in it, 0 electrons. CH3, CH2, CH3. So we'll get CH3, CH2, CH2 plus H plus. So this is how the alkyl groups are formed, by removing hydrogen from the alkane groups. Easy, no? Are you finding the questions difficult? Just let me know if you have any doubts. Okay? Define or explain chain isomerism and position isomerism with examples in each case. So chain isomerism is where there will be difference in the carbon skeleton. Okay, so in the arrangement of carbon group, that's it. So if I have 4 carbon atoms, they'll ask me to arrange 1 or 2, right? So what is the difference here? The molecular formula will be same. If you add hydrogen to satisfy the valency of carbon, the molecular formula remains same. But the only difference is, look at the carbon skeleton. There is a difference in the arrangement of carbon, right? So these kind of isomers are known as chain isomerism, chain isomers. So I have C4H10. So as they have asked us to explain using an example, so C4H10 is butane, we all know. So I'll write CH3 hoga G, and this will be CH2, CH2, CH3. 3, 3, 6 plus 4, 10, C4H10. Okay. Now let me write the structural formula of this particular compound. CH3, CH3 hoga. This one also will be CH3, and there will be H here. Let's count the number of atoms. Carbon to 4 hai, hydrogen 3 plus 3, 6 plus 3, 9 plus 1, 10. The molecular formula is same, C4H10, but what is the difference? There is difference in the arrangement of carbon skeleton or carbon chain. Please, when they have asked you to write the explain using an example, make sure to write the structure. So there is no, so this hydrogen must have been here. So the problem is we prepare the slides in the Google slides, and then we have to convert it into PPT. So that is when the structures of few compounds might get disrupted. Position isomerism. So it is due to the difference in position of functional isomerism. So there is change in the position. Position of what? The functional group. That's it. For example, I can write 2-butanol or 3-butanol. No, right? 3-butanol is not possible. 2-butanol, that's it. So, or wait, I will show it to you. C. 1-butanol, 2-butanol. It is possible, no? So CH, H, here also H, CH3. So this is butanol, 1-butanol, because the alcohol group has been attached to the first carbon atom. Now I'll remove this, I'll replace the OH group here, and ye hoga H. So now this is 2-butanol. So what I have done, I have only changed the position of the functional group, and they are called as positional isomers. So here they have taken a different example. This is also works well. So the molecular formula is C3H2Br. Okay, so can we write it in, can we give two different position to the bromine? Yes, we can. So first, end of the chain, terminal carbon ko attach kar do, and the second one, give it to the second carbon. So for that is how, this is how it looks like. Okay, first Br and H2, CH3, bromo, propane. Or this one, other one, I'll attach bromine group to the second carbon atom. So do 2 bromo propane or 2 propyl bromide. Okay. The next question, draw the structural formula for each of the following compounds. Isomer of N-butane. They have not asked you to write the structure of N-butane, so do not get confused. So N-butane is CCCC, straight chain. So its isomer will be isobutene, right? But what will be the structure? Let's just go one by one. So CH, CH3, CH3, right? So this will be the structure, but if you write the structure of N-butane, you won't get any marks. Vinegar, it is formic acid or acetic acid? Acetic acid. So how many carbon atoms should I write? 2, right? See, functional group mein already एक carbon hai, and that we have included while naming the compound. So don't write acetic acid. So 1, 2 acetate, that is eth, and one more carbon atom in the functional group. This will become propanoic acid. Okay, so OH, this is our functional group, and this is the acid. CH3COOH is vinegar or acetic acid. The last one is propanol, 2-propanol. So first let me write 3 carbon atoms. It is because it is prop and ane, no multiple bonds, but the position of the alcohol functional group is given. So I need to add OH functional group to the second carbon atom. Now satisfy the valency of carbon by adding hydrogen. 1 2 3 1 2 3 है और एक hydrogen इधर, and done. So this is C, this is B, this is A. Got it? No confusions? Pakka? See? Hi Ram, क्या हो गया? CH3, 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 H. What is the common name of this compound? What is the IUPAC name of this compound? I'll check the chat section, okay? Let's see. I feel really sad. What has happened to our structures? Okay, so the last question, draw the structural formula for each of the following. 2,3 dimethyl butane, okay, diethyl ether, propanoic acid. So 2,3 dimethyl butane. So first, this is the root word. Let me write 4 carbon atoms. Then to the second and third carbon, methyl groups have been attached. A second है, A third है, or if you have to count from left to right, A second है और A third है. CH3, CH3, A हमारा methyl groups है. Then satisfy its valency. CH3, 1 2 3 H, 1 2 3 H, 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 H. And one more thing, as they have asked you to write the structural formula, show all the bonds. Okay, do not write the condensed formula. You know the difference, right? So this is 1. Next is diethyl ether. Where should I write? Wait. So you have basically, so this is how it looks like. As it is ethyl group, so बीच में आपका ether group होगा जी. So it will be CH3, CH2, CH2, CH3. This is diethyl ether. See? CH2, CH3, CH2, CH3, and ether is the functional group. The last one, propanoic acid. So 3 carbon atoms and 1 carbon atom among them should have the double bond O, OH. So that is what is propanoic acid. CH3, CH2, C double bond O, OH. And practice the structural formula or the IUPAC nomenclature with lots of compounds, you know. Okay, you will be reading something. You see butanoic acid. Fatapat se, or try to imagine. So what must be the structural formula? You know, that will help you a lot. That will make it, you know, easy for you to understand the nomenclature or how to write the structural formula. Yay! So this, we are done with vital force theory, classification of organic compounds, nomenclature, isomerism. And here is your homework question. What are organic compounds? What is the vital force theory? Why was it discarded? Interesting question. So I'll be expecting the answers in the comment section. So make sure to write the answers in the comment section. So thank you so much. The next session, that will be our last session. So do not forget to watch it. Organic chemistry part 2. It will be premiered on 1st March. And today we learned about the organic chemistry. The previous session was on study of compounds. If you have not watched, go back and watch it. And let me remind it to you again about the limited period offer. So 50% off up to 1,500 rupees. The link is in the description and in the pinned comment. Use the coupon code SURPRU to avail 50% discount. SURPRO is the code. See, 3.3 rupees per class, which is very much less than our lace. What will you get for 3 rupees, man? Ek limbu lemon milega na? No, that is also 5 rupees these days. So thank you so much. Do not forget to subscribe to the channel if you are here for the first time. Like this session, share this video with your friends as well. Click on the bell icon so that you will be notified whenever we are live or premiering the videos. Any doubts or queries, you can reach out to me at surabhi.r@vedantu.com. Thank you so much. Bye bye. Take care.